All right, so we're in building 32. Who are you? What exactly am I doing here today?
Sure, Ruston Panabaker. I'm an architect in the mobile and tailored PC division.
Interesting.
So part of Bill Mitchell's organization, we used to be called the Hardware Innovation Group within Windows, but we've recently been orged into with the mobile team that's building the ultra mobile PC and does the tablet functionality. Now we have a bigger charter to go and build new tailored PCs that are tailored to what users do.
Excellent.
Yeah.
So I noticed you have a number of PCs on your desk here.
Yeah, and actually what we were going to chat with you about today was a new feature in Windows Vista, which our team played a big role in helping to develop with some other teams around the company, which is support for hybrid hard disks.
Interesting.
So a new type of hard drive.
Okay.
And this new type of hard drive incorporates a flash memory into a traditional hard drive design.
Wow.
So that we can do some interesting things with that flash.
So in other words, there's no disk. Is that what you're saying?
Well, there is so these hard drives still have a platter like a standard, as all mobile hard drives do today.
Okay.
But now this buffer allows us in Windows Vista to put the right things into the flash to get higher performance, to actually spin down the drive to save power.
Wow.
And also by spinning down the drive, we also make the drive more reliable while you're walking around bumping your laptop into door jams, etc.
Fantastic. So it sort of caches things that you need.
That's right. So the feature in Vista is it's actually called ReadyDrive, is what the marketing folks have termed it, and that's the support for hybrid hard disks like the software in Vista.
Okay.
And ReadyDrive essentially is the intelligence of figuring out what should we put into that flash buffer. Say it's 128 megabytes or 256 megabytes of flash in the drive. What are the right pieces of the disk content to put in there in order to get maximum bang for our buck in Vista?
Interesting. Now, aren't traditional disks, isn't data distributed all over the place?
Yes.
So
And that's actually
interesting.
Well, that's the whole reason for this technology being valuable, is because on a standard hard drive, Windows is just always jumping around mechanically to the right look, and almost 50% of the data accesses on any given benchmark are random 4K IOs, and so you suffer all these really long seeks while the mechanical disk, like the ARM, is actually seeking around. And so a lot of people don't realize that the data rate that we get from a hard drive quite often drops below a megabyte per second because of all these seeks. Now, for the data we have in the cache, we can sustain 4, 8, even hopefully someday 60 megabytes per second out of the flash without incurring any of those seek penalties.
Excellent.
So that's where we get the performances from random I/O that Windows incurs.
And as you mentioned earlier, this will also help with battery life and perhaps even processing heat.
That's absolutely right.
Very important.
That's right. So for mobile PCs, right, battery life is really important.
Yeah.
And so what we actually are doing is once the system gets up and running and we've sort of stabilized from an I/O perspective, and the Windows Superfetch technology has pulled what it needs up into main memory. Now, if you're running on battery, so if we know that the machine is currently not plugged into the wall, we send a command down to the drive to go into low power mode, and it spins down the mechanical portion of the spinning portion of the drive, and now we're just operating all the writes that Windows is constantly trickling out to the hard drive are being essentially buffered into the flash memory. So we leave some amount of space in the flash for this buffering, and all the trickled writes that are constantly going out while you use Windows, or even while Windows is just sitting there, we're trickling out writes. Those all get buffered up into the flash, and you only need to spin up the drive when that flash gets full, which typically is a fairly long period of time with the typical write rates, or a read occurs that can't be satisfied from the flash memory, then the drive automatically will spin up, get it from the mechanical portion of the drive, and then spin back down again.
Got it.
So, what we're seeing right now with RC1 and actually from Beta 2 onwards, we've had this working very well, is we're seeing typically being spun down for like real world users and BATSAT benchmarks around 50-60% of the time.
Wow.
So even while you're physically or like manually sitting there in front of the machine using the machine, being spun down more than half the time. When the machine's idle, which we don't realize how often machines sit there idle, we're being spun down 96-98% of the time. So, for example, in a meeting, it wouldn't be uncommon to go into a meeting and only have your drive spin up once or twice during the entire meeting because it's just sitting there.
Excellent. That's very cool. Now, do you see this hybrid technology migrating into desktops? Do you see a need for it there at all?
You know, when we first started this, the feature set was just so well matched to mobile systems that we really didn't push that at all, and it hasn't been our design goal. But there's nothing, if you put a hybrid disk in a desktop system in Windows, it will use it and will cache the content in the flash, etc., etc. We've even done a few things to spin down the drive when the user is not active in the system on a desktop. Now, though, that we've gotten further along and we've started to see the performance benefits, now we're starting to see a lot more interest from OEMs in terms of, hey, you know, especially as the price of flash continues to drop like a rock, and the performance. One of the things that people don't realize about flash memory technology is the performance of flash is doubling every 12 months as well. So now you can, you know, it's getting to the point where the hard drive is only getting faster at 10% a year thanks to rotational speed and just the density of data on the disk. But flash memory doubling each year, it's going to get to the point where to get the best performance and the highest Windows, Windows Experience Index scores, you'll need a hybrid. You'll need a flash memory in the disk or in the storage subsystem somewhere.
Fantastic.
So I do think you'll see it in the desktop. There's also people talking about server workloads that might be applicable for this technology.
Now, clearly, you'd be using. Could you use this in a smartphone? Which is purely
yet another thing that people have been talking about. We've talked with a couple of the hard drive vendors who build really small embedded hard drives, like 1-inch hard drives, etc. They think there might be a market for this sort of technology. Personally, having done a little bit of embedded work, I think that in an embedded device you can probably build the flash outside of the drive and end up with better cost curves, etc., and more flexibility from a design point. But some of the embedded folks are thinking that it is an elegant solution, so we might see something there. We might see it in cell phones, MP3 players, you know, anywhere where there's a benefit from spinning down the drive and getting higher performance.
Now, are hardware developers of laptops starting to are they going to target Vista specifically with these hybrid?
Yeah, well, this is a Vista only feature, right?
Sure.
So it's one of the few examples. I'd say this and Sideshow, the aux display, which is another thing that our group has previously done. These are some of the only examples of things that are Vista only. Okay. So yeah, the goal is to have laptop vendors pick this up, you know, from Vista launch onward. As our partners come online, the hard drive vendors start producing these. So I'm hoping that during 2007 we'll start to see adoption, and we're currently slated that we become a premium system requirement for for laptops in 2008. So at that time, you know, any laptop being sold that wants the premium Windows logo should have a hybrid disk in it to get the performance benefits and be a premium system.
Excellent. So do you have any, can we look at this? Or?
Yeah, so a couple of things first. What you're looking at on this system is system is running one of our prototype hybrid hard disks. And I'll just put it right out in front of you here. Is that an okay shot?
That's great.
So this is an actual prototype which our team here built, and it's a functional hybrid hard disk system. It uses a 1.8-inch hard drive and a compact flash memory, and it has a full implementation of firmware that emulates the new command set. So we're standardizing on a new ATA command set for the hybrid hard disk, and it's in this system, and what it's showing you is whenever it's in green here, it's showing you that the drive spun down. So here we were spun down for 245 seconds, and during that time, almost a megabyte of writes trickled out to the drive just while it was sitting there. So, and whenever it's orange, or pink, you can see that's a period of spin up where something's occurred that required the drive to spin up.
Very cool.
Okay, so that's the one example. Obviously, with a standard hard drive, the drive would need to stay spinning the entire time because every single write that goes out would require it to be spun up. So the other thing I can show you on this same system is, let me start a workload. So this demo we have, this is just a demo script which launches a series of applications while there's some other disk activity going. So right now we're starting an I/O workload, which means that we're starting some data activity on the disk. Very typical of you multitasking on a system. And now you go to start launching your favorite applications like Outlook, etc. I'm going to run that same workload over on the standard system, which is running just a standard hard drive. And what you're going to be able to see is how long it actually takes to launch these applications. And the reason why we're going to see a performance benefit in the hybrid system is because we don't have to incur all of those seek latencies, and the drive's not jumping around getting a low data rate from all this multitasking. It's actually enjoying a higher throughput because some stuff's coming out of the cache, which Vista has automatically determined what to put in there, and the stuff that's coming off the drive is coming off more efficiently as well because it's not getting interrupted by the stuff that's coming out of the cache.
I see. So that one on the left just now launched Outlook.
You're right. Yeah, the demo takes a little. We're going to see that this will take significantly longer. And again, this is a specific scenario which highlights the performance because there's, this is like you're ripping a CD and you're trying to also use an application, right?
Got it.
And you're all familiar with this. When Windows bogs down in performance, a lot of the time what's happening is the hard drive you're trying to do multiple things with the hard drive, and so the hard drive is jumping back and forth across the face of the hard drive, trying to get 4K here, 4K there, 4K here, 4K there. Right. Really hard thing to optimize for.
Absolutely.
So you can see that here we ended up with our time, so we ended up at 44 seconds for the standard system and 26 seconds for the hybrid system.
Very nice. Almost half.
Yep.
That's great. So how is this, obviously it's very different than Superfetch, but it seems to solve a similar problem.
Yeah.
Not really though, but Superfetch is the Vista, you're able to launch applications really fast because it basically holds a copy of it in memory.
That's right. And this is actually part of the same family. So the group that actually has done all the development on this stuff, I have to make sure to give credit, is the Windows Performance team. And they're the same group that's implemented the Superfetch technology.
Great.
And so we're using the same algorithms that we use in Superfetch to figure out what you as a user need up in main memory. Well, we use those same algorithms to say, well, what do you as a user need cached in the hard drive to get maximum performance from the hard drive. So both Superfetch and this technology and the ReadyBoost technology, which is also done by that team, all of these are trying to get around disk performance, right? So we actually, all three of those technologies we refer to as Windows PC accelerators.
Nice.
All right, so that's sort of the marketing team has this name for these technologies, which are things we're doing to accelerate performance.
Cool. Well, and clearly you are. It makes sense.
Yeah. A couple other things, which I won't try demoing for you, but we also, when you shut down the system, a Windows system with a hybrid hard disk, we actually cache the data you'll need to boot the system, the initial data that you'll access during boot. And so what it means is that when your system starts, we no longer have to wait for the 3.5 to 4 seconds for the hard drive to spin up. If your BIOS is fast, we can start booting off the disk almost instantly.
Fantastic.
And save that time. And then also because of this, because there are still a lot of random activity during the boot process, and we're really held by the disk in the boot process, with a hybrid system we're seeing boot times 5 to 7 seconds faster than with a standard system. Cool. So, as opposed to a 30-second boot, we could now get down around a 20-second boot, if that's a particular system, for example.
That's great.
And we do the same thing during Hibernate. So we put the first portion of the Hibernate file into the flash, and when you go to resume from Hibernate, again, don't have to wait for the disk to spin up. We can just start resuming from Hibernate, and then when we run out of data in the flash, it just automatically keeps getting it from the data that's on the disk.
Cool. And I've noticed even in Vista without a hybrid hard drive that it's coming out of hibernation faster.
Yeah,
It blows me away.
They've done some really good work in terms of figuring out what to take down into the hybrid file and make the hybrid file smaller, etc. So, again, if you're getting great times with a standard mobile hard drive for resume from Hibernate, the hybrid disk should only be better. All right?
Cool.
And as the performance of flash gets higher and higher and higher for both random and sequential reading, we hope to see the benefits of hybrid drive get better and better and better.
Absolutely. And according to your trajectory of performance, it seems like why would I want to have in the future? Why even have mechanical disks?
Well, and so that's the the obvious question is why not just go completely solid state? And in fact, I do also play with like 16 gigabytes of solid state disk, and I play with Samsung has some 32 gigabyte solid state disks. The problem is these are like $600 for 32 gigabyte solid state disk, and even though that's dropping in half each year, I'm currently thinking that it's not going to be until 2010, 2011 that you even start to see a significant niche of solid state disk appear just because of price. Whereas with a hybrid disk, we can just add 256 megabytes of flash, which is $3 to $4 today and dropping. And we can get significant performance because because we have the intelligence in Vista to figure out what to put in the flash. And moving forward, as that we start to put 512 megabytes, 1 gigabyte, 2 gigabytes, we'll eventually get to the point where you'll be able to have 2 or 4 gigabytes of flash in a hybrid disk, and then terabytes in the rest of on the mechanical portion of the drive, and we'll be able to operate the PC at highest performance, potentially not spinning up all day unless you access a piece of media or you launch an application which you haven't launched in months, or because the actual working set of the disk will be able to fit inside the flash portion.
So the other thing that the question I would ask also is if you had a normal disk but you had 12 gigs of RAM, all right. Now I realize for 32-bit this may not make a difference, but and that's because it can only uses so much.
Sure.
But couldn't you just use RAM?
So, and that's the superfetch question, right? If superfetch is filling up your 12 gigabytes of RAM, it sounds weird to say today, but you're right. Once superfetch has populated memory, you're going to get the fastest possible performance.
Sure.
The thing is, on a mobile system where people are, for example, you play a game and the game just allocates all the memory because it wants to have as much memory as possible. It pushes everything, the superfetch data, out of memory and pushes the standby list out. When you then go and close the game and launch Outlook, you could be in that thrashing situation, right? So we call those memory transitions, and it's during those memory transitions that the performance of storage, even with superfetch, is going to stay really important. Right? So you close Photoshop, which has been using all of your memory. You go and launch Outlook. And that's the situation where the hybrid hard disk is going to add performance. The other scenarios that are really important, right after you've booted the system, right? Superfetch hasn't populated yet, right? Well, now we have the right stuff in Flash, launching Outlook and launching Photoshop and launching Acrobat, whatever you normally do is going to be as fast and consistent as possible because it's cached in the hybrid hard disk. And superfetch, your 12 gigabytes of memory, will populate much faster following Hibernate and following boot because some of that will also be in the cache.
Excellent.
Right? Because it's the same prioritized data. So instead of taking 3 minutes to get up to full performance, now it might only take less than a minute before you've ripped all that, or 30 seconds to rip all of the superfetch data up into RAM.
Cool.
So the two together are really what provides, superfetch provides you that steady state performance when RAM's hot and RAM's full. But when you're in a cold memory state, this is where the hybrid hard disk is really going to help.
Excellent. And are we seeing a lot of, I just bought a new laptop, and positive it's not.
Yeah, until Vista ships, and actually right now, great question, our partners are building hybrid hard disks. The hard drive vendors are building hybrid hard disks.
Cool.
So we've got folks like Samsung building SATA-based drives. We've got drives in here from Seagate. Is this public? Is this Microsoft?
This is Channel 9.
Channel 9 is public. Everyone. So we have, those are the two announced partners. We also have drives from some other vendors as well.
Great.
That we're testing out. And the goal is, public announcement-wise, Samsung's announced product availability in January, and Seagate's announced availability in the first quarter of 2007.
Excellent.
And so we hope to see all 6 of the mobile vendors be in the marketplace, sometime after that.
Awesome. That would be great. So, what else? How did you get this to work? So you said you're using algorithms developed by the team that made superfetch. So what have you been doing specifically? Like what's your role in all of this madness?
So after sort of proving out the concepts and doing some of the initial work with the performance team and the storage team, our role here has really fallen back into one of prototyping, right, the experience so that we could actually finish the code in Vista while the partners were still architecting. And we also are the ones who work directly with the hard drive vendors and with the PC OEMs to explain the technology and to help them with their implementations. So, you know, it's been a really great cross-group effort in terms of, you know, performance team doing the development work within Vista and making sure the algorithms are optimized there. The storage team doing the work that's needed there to help storage partners, and ourselves, you know, interacting with the marketplace, with the partners. Right?
Very cool. Who seem to be pretty excited about this technology. Huh?
Yeah, I hope so.
Good. Well, that's impressive benchmarks. I mean, very cool.
Yeah.
So, what else do you want to talk about?
You know, we talked about the performance benefits, and
I have a question for you. What about security, especially in the boot?
Sure. Well, from a security perspective, we kind of match the security of the hard drive and the system that you're using. So if you have a technology like BitLocker turned on, the content is already encrypted by the time it gets seen by the hybrid drive.
Okay.
If you're using hardware encryption on the drive, same thing. You know, the interface to the drive is still encrypted. So it's kind of a tangential thing for us, you know, as to what security is being used by the system.
Okay.
The new commands are really just saying, pin this specific data into the cache so that if it's ever read in the future, it can be read at low latency.
Very cool. Excellent. Well, I'm looking forward to seeing this myself because I'm a laptop user.
We'll make sure you're on our list of data.
Yeah, please. Very cool. Well, hey, it's great to meet you and talk to you.
Yeah.
We'll get this up on Channel 9, and I'd like to see one of these in action. I mean, we did here, but with real device.
Sure. Yeah. As soon as we have partners that want to show off their wares, we'll make sure that you folks get a look at it and get to see the best storage available for Vista.
I can't believe I almost ended this. I do this all the time, right? I'll have interviews and then I'll start the ending sequence, but then realize that it's not time yet. So, but Channel 9 people are used to that. For developers, it means nothing to me as a developer. As far as wanting to read and write stuff off the hard drive and anything else, is there any way that I could like force maximization of?
Great question. Yeah, and that brings up another feature of hybrid hard disk. So there's nothing a developer has to do. Like the super fetch algorithms are always running, figuring out, you know, whether it's part of a PowerPoint presentation or part of a third-party application or part of the OS that should be prioritized for the flash. But we do provide a feature for the PC manufacturers, the PC OEMs, where they can go into their registry settings in the factory and actually specify files or pieces of files that they want cached. And so as long as there's a significantly large non-volatile cache, like flash memory cache in the drive, we'll let OEMs pin specific applications or boot sequences of applications. And so what that means is that, you know, it allows the PC manufacturers to differentiate and make sure that their applications are as good a performance as possible. Okay. And so, you know, another option there is that in the enterprise, a group policy administrator might decide to take those registry settings and put in their line of business applications, right, etc. But today we don't have any. You know, we wanted to keep it really, you know, simple and system level. We really didn't want to make it so that a developer had to learn a new framework or a new object model to get benefit out of this.
But in the end, I think it's a good thing because whenever you give application developers the chance to take control over priority, I mean, think of threading on Windows. There's a ceiling of priority that developers are ever going to get.
And then everyone has to play well together, and everyone has to guess what the user really, right? So, and this is just classical architecture, which is who's the right person in the system to optimize across, you know, all system resources. And in this case, we have one hard drive that we have to share among all these processes, etc. And so the system level control of this and you know, another question that we got early on from the hard drive vendors was, well, why doesn't hard drive figure out what to put in the cache? And it's just not possible, right? The amount of data that we're talking about, heuristically, the hard drive controller just doesn't have access to the wealth of information that we have in the operating system about memory pages that have been accessed by which process. Were they random accesses? Were they not? How long did they take? You know, we can take that information and translate it into algorithms that optimize what we put into the cache.
Very cool. And of course, you're working with the Windows people, right? You got Landy Wang, memory manager dude.
That's right.
He's a good algorithm creator.
Yeah.
Amongst many others.
Yeah, you know,
Very cool.
and way out there in future versions of Windows, you know, because Flash is going to continue to ramp in performance. You know, the question is what next? Like, how else do we use Flash in the system to increase performance?
Yeah.
And I think you guys have featured ReadyBoost in the past, where you can plug a USB fob into the back of a Vista machine to get a performance boost by caching pages. You know, that's a sort of a sister technology to this. Superfetch you mentioned. So there's lots of interesting things we can do moving forward as we, you know, now that we have these rich capabilities down at in the core of the OS.
Fantastic. Yeah. Excellent. Well, on that note, thank you for your time.
Okay.
Very nice to meet you.
Take care.